Onboard safety guarantees for racing drones. High-speed geofencing with controlled barrier functions. The goal of this paper is to keep a drone inside a geofence-safe region of space, shown in blue. We utilize a backup controller to construct an invariant backup safe set. The backup controller takes the drone from any point in the backup safe set to the backup set. To do this, rather than using standard backup controlled barriers, which are too computationally expensive, we use a smooth regulation function which switches between the pilot's desired control and the backup controller. As the drone approaches the boundary, lambda goes to 0, which puts the backup controller fully in control. On the left is our backup controller recovering from a variety of falls. Here we show our barrier's operation during a free fall. The quad rotor is taken to 70 meters and then given 0 control input, which means our desired throttle is 0. The figure on the left shows the safety filter throttle against time. Here we show the barrier operating at slow speed in the x direction. Next, the drone is shown repeatedly going against the x barrier. The plots show the velocity and position versus time. Next, we show our barrier operating at high speeds. The tuning for lambda was unchanged between all of these tests, demonstrating that our system is robust to multiple speeds. In this test, we reached over 100 kilometers an hour. Plotted below are position and velocity relative to time. Here, a loss of radio connection event is shown. This is in the case of no safety filter and results in a crash. Next, a simulated loss of radio is shown with the safety filter engaged. The drone regains stability and ends hovering above the ground.